Okay, so today let's talk about this LeetCode problem 456 132 pattern. Given array of n integers, a 132 pattern is a subsequence of three integers, numbers I, numbers j, and numbers k, such that I is less than j, j is less than k, and numbers I is less than numbers k is less than numbers j. We need to return true if there is a 132 pattern in the numbers. Otherwise, return false. The follow-up says the ON squared solution is trivial. Could you come up with the ON log n or the ON solution? So we need to implement a solution that has ON log n or ON time complexity. Now let's take a look at these three examples here. In the first example, we are given 1, 2, 3, 4. Since all the numbers in this array is increasing, so we can't find any three numbers that can form a 1, 3, 2 pattern. Right? In the second example, we are given 3, 1, 4, 2. 3, 1, 4, 2. As we can see, the last three integers can actually form the 1, 3, 2 pattern, right? So say 1 is at index I, 4 is at index j, and 2 is at index k. I is less than j, j is less than k, and also numbers I is less than numbers k, and numbers k is than numbers j, right? So we can find the three numbers in the second input array. So in this case, we need to return true. Okay, in the last example, we are given -1, 3, 2, and 0. Right? We can see the first three numbers, it can form the 1, 3, 2 pattern. Right? Also, we can see -1, 2, 0. These three numbers can also form the 1, 3, 2 pattern. So now the question is, how can we design an algorithm that can help us quickly identify whether an array has three numbers so they can form the 1, 3, 2 pattern? Let's make the example more generic. Let's say we have array A0, A1 to AI, and then we have AI plus 1 to AN minus 1. So this array has n numbers. So at any random index, say AI, we can actually divide this array into two parts. The first part is from A0 to AI minus 1, and the second part is from AI plus 1 to AN minus 1. So essentially, our goal is to find two numbers, say M1 and M2. So we need to find M1 in the first part such that M1 is less than AI. And also we need to find the second number M2, that M2 is less than AI but is greater than M1. So M1 should less than AI, M2 should less than AI, and also M1 should less than M2, right? So our purpose is to find these three numbers, M1, AI, and M2. Okay, so we may realize that M1 is relatively easy to find. We just need to traverse the array from left to right, and then we keep a prefix array which tracks the minimum number that between AI to AI minus 1 for index I, right? So we can always find the smallest value before AI to help us form the 132 pattern. For M2, we need to find such a number that is between M1 and AI. So how can we do that? So we can traverse the array this time from right to left. And meanwhile, we can maintain a stack. The stack, how can we maintain the stack? Because we know the M2, right, needs to be between M1 and the AI. So we can use M1 as the lower boundary, which means any number in the M2, if it's less than M1, we popped it out, so that we can make sure all the numbers in the stack is greater than M1, so that we can at least satisfy this condition. And then we just need to check whether there is a number in the stack that is less than AI. If there exists such a number, M2, then we know, okay, we find the M2, right? In other words, we find the three numbers that can form the 132 pattern. Okay, now let's code it. Let's first check some content case. If numbers is null, or numbers has less than 3 numbers, we just need to simply return false, right? Now let's find M1. Let's define an integer array. Let's call it min. And let's say the current min is numbers I, numbers 0, sorry. And then we just traverse the array from left to right. Okay, we keep updating the current min by using the minimal value between current min and numbers I. And then we just update the min array. Okay, so this is for the M1, right? Or we should say AI, or we say M1. Okay, now let's use the stack to find M2, which is a numbers k. So this is numbers I. Okay. In the explanation before, this is gonna be M2. Right, we traverse the array from right to left. Right, we use M1 as the low boundary to pop up all the elements in the stack that is less or equal to M1. And also we need to check, like, if this is numbers I, and this is a min I, right? So we only do that logic when numbers I is greater than min I, right? Because otherwise, you know, M1 and AI in such a case won't satisfy the 132 pattern, right? Let's check it. If numbers j is greater than min j, we do the logic, otherwise we just skip it. And eventually we need to return false. This is by default. Okay, now let's use M1, which is numbers j, to pop up all the elements that is less or equal to M1 in the stack. We keep popping the value. Right, and once we done this, we just need to check whether there is a value in the stack that is less than numbers j. If yes, we return true. Otherwise, we pop the current numbers j to the stack. Oh, sorry, push. And let's submit it. Okay, so by using the stack, we can, so this is just an ON traverse, right? And we traverse from right to left, so this is ON as well. So overall, the solution is ON. And since we are using array and a stack here, so the space complexity is ON as well. Okay, that's it.